we're here today to talk about a solution that IMDEX has developed in response to the challenges and complexity that miners are facing with respect to their ore bodies. That solution is BLASTDOG, and it's about a high-resolution understanding of the rock mass or the ore body from the mining bench. And specifically, these two gentlemen to my left today, John, who works with IMDEX, and Max, who works with a good customer of ours, to talk about the journey specifically at the Anglo-American Dawson coal mine. So thanks, gents. Max, could you introduce yourself and tell us a bit about your role at Dawson?
Yeah, hi. So my name's Max Aliff. I've been working for Anglo for about 20 years, and my current role is geoscience, operations and governance specialist. That role basically works across the Dawson operation, looking at operational systems, trying to improve our processes on site to basically provide the best inputs into our mine planning and operational processes. And Dawson Mine, one of those key projects has been the implementation and development of the BLASTDOG system with IMDEX. And the whole idea of that is to use both geophysical data and drill rig data, MWD data, to basically characterise the rock mass so we can use that in our planning processes in drill and blast optimisation, and then also in operational control processes.
Thanks, Max. And John, a bit about yourself and also your role with the BLASTDOG.
Hello everyone, I'm John Jackson, Global Technology Manager Mining for IMDEX. The role for BLASTDOG I was there at the beginning, and it's evolved over time, starting off with working with our engineers around the sensors in the probe, and then collaborating with our robotic partners, UFR, and we'll get on to how that came about a little bit later. And then more recently it's been on moving from the data into information knowledge to enable decisions to be made on site and the processes that are involved in that.
Thanks, John. Dawson was the host site for a large part of BLASTDOG's development. Max, why did Anglo-American choose to partner with IMDEX?
So Dawson and Anglo-American decided to partner with IMDEX. It was mainly for the development of high resolution capture of downhole geophysical logging. Dawson Mine, some of it was a large operation, and we drew more than 70,000 holes per year, and massive opportunity there to gather more information out of those holes. And traditionally, we've only ever probably logged, less than 0.5% of those holes. But bringing the BLASTDOG system on board enabled to significantly increase the number of drill holes that we could log. And now with using the IMDEX system, we're getting somewhere between 7,000-10,000 holes at least a year logged by the IMDEX BLASTDOG unit. So it's significantly increased the amount of data that we get. And not only it reduces process that we need to do on site in terms of actually trying to log the holes, and it actually puts a process for not using radioactive sources. So it's a sort of real step change for us from our blast hole logging. But then the other key thing to do is we had a number of MWD units on our rigs, which basically has high volume, like sort of really noisy types of data, and we wanted to integrate it into the system. And so through the process that BLASTDOG uses, its data set helps find the truth to a degree.
Thanks, John. Sorry, Max. And John, why was Dawson a good fit from the IMDEX perspective?
So the development was part of a collaborative project with Mets Ignited, and the participants were resource company participants were Teck and Anglo-American. There was each company had to select a site from which we were to develop, test, trial on. Teck chose a porphyry copper. Both companies had coal assets, so Anglo chose a coal asset, and that just happened to be Dawson. For us, Dawson was a fantastic opportunity because it is a very large, multi-seam operation over 60 kilometres. It has contract miner and owner miner, so it had both mixes, mining types. And if we could get BLASTDOG working in an environment like that, then that stood us in good stead for other operations, other commodities.
Mining is rarely easy, but Max, what are some of the typical challenges that a coal mine faces? But also, what were your early expectations for the BLASTDOG project and how it might address those challenges?
So, as we've alluded to, Dawson's a very large operation. It's over 120 kilometre strike length, of which we work about 60 kilometres of that. And it's so large and it's very historic. It's been running for 50 years. We have a lot of areas that we can't actually get exploration data in now. And so we rely heavily on that very near-term definition using our BLASTOGs. And so for us, having a system where we could log a hell of a lot more blast holes, like BLASTDOG, provides us another set of data to use. And then we incorporate that with the MWD information and also pit survey. We're starting to get the best picture of what's going on in the pit. And, the key challenges that we're trying to define are things like seam splits and coalescing, where you get a variation in what the seam looks like and a variation in qualities. Things like thrust faults and normal faults that we see in the pit, we want to define them because that all impacts the quality of the coal that ends up on the ROM and going into the plant. So it's trying to optimise and understand the best what we can see coming out of the pit. The beauty of the BLASTDOG unit and the integration of that data sets is, like when we started to log some of these pre-splits, as you'll see from the images behind us, you get an amazing image of what the walls look like, and you're actually getting that prior to mining. And so that's giving us an insight in what the geological package looks like before we've actually mined it. So amazing sets of data to be able to integrate together.
Yeah, and from our point of view was to develop a system that was automated and we could provide information to our two key constituent groups on site, which were the geologists and drill and blast engineers, in a timely manner to basically manage risk and take opportunities that they could see. It was really around, initially, it was around identifying the seams and the partings within the seams, and then moving into creating automated surfacing, and then looking at the overburden from a drill and blast perspective. Where are the structures? Where are the faults? Where are the areas that could cause issues? And one of the early lessons we found, particularly in the pre-splits, which you'll see a photo of one of them come up, and the whole deviation caught a lot of people by surprise. The holes were moving as much as we were measuring, and we were identifying zones and holes that were coming together, and from a drill and blast perspective, posed risks around misfires and cut-offs and other issues.
What were some of your big challenges? What caught you by surprise?
Look, there's always challenges when doing some of these sorts of projects, and one of the ones was turning up with a small semi-autonomous robotic digger onto a site like Dawson, and then trying to get that through the gate from a safety perspective and approvals perspective. That's no small mean feat, and the numbers of risk assessments and processes that we went through was just incredible. Getting our MWD systems functioning and providing the data to feed into the whole process has been a major challenge. We've got different rigs of different vintages running different systems, and so trying to actually wrangle that together to be able to make sense of it and make these beautiful pictures that we see, that's a tribute to some of the BLASTDOG analytics that we're using. You know, new scene, new process, new logging type unit. You know, we had depth issues, challenges, zeroing of the top of the hole issues. We've got 3 different types of data. We've got MWD, we've got our own, we've got the BLASTDOG, and we've also got some exploration holes that we would also do checks, and they're all slightly offset, and that causes numbers of headaches over the years. And then, you know, things like GPS locating and those sorts of things of trying to know where zero is really in the air once it's gone. They were all major challenges.
I'll just jump in here. It's such a simple concept of knowing where the start of the hole is. But as Max alluded to, we've had many discussions over the years to try and understand exactly where the hole is, because the drills have, yes, they have their system, there's manual intervention of when the driller calls zero at the top of the hole, integrating it with other data, and you end up getting these small offsets that just provide significant challenges. It's so simple. Top of the hole, zero, it's at surface. Not so easy in practice.
Yeah. Probably the big one is getting people with the new, you know, like geologists, coal geologists live and die by using density as their way to pick the coal seam generally. And to get people to change from using, you know, a density sonde response to using conductivity and gamma has been a challenge. And, you know, we've been working our way through that with various comparisons and those sorts of things to get people comfortable. And then probably the thing for us is getting people to be able to get the process. And we really need to give the overview of the context of the data. Yeah.
Oh, so one of our challenges was when we first went to site. Our original plan was to log the holes manually and then prove the value of the data and then move to automation. However, when we first went to site, and this is a picture up behind me at the moment of us looking at a blast hole cone, the drill and blast superintendent said, you want to log as many holes as possible, preferably all our holes, on a hole pattern. Yes? Well, that's going to be very difficult for us, because in order for you to do that manually, we have to put a gas bag down the hole, we've got to clear, we've got to remove the drill cuttings, then you've got to come along, find the hole again, remove the gas bag. That isn't really practical, and it isn't going to happen. Go away and find an approach where you can log the hole without touching the cone. And that's where the little robot, the 1AS, came from, was that concept, and we went away, collaborated with UFR, and that was our first challenge of how to log a lot of holes in a timely manner efficiently without touching the cone and creating more fallback.
So so far so good by the sound of it. Early insights, Max, in terms of what you're seeing, what the team is seeing, what the response has been, but also if you can touch on what's got you excited about what's to come with BLASTDOG at Dawson.
I think the thing for me is we're getting a definition like we've never seen before. Like, we typically have exploration holes at a couple of 100 metre spacing or more. All of a sudden now, you know, where we're logging, you know, a high proportion of the holes on our bench and also integrating D&B, we're starting to get a picture at, you know, sort of like a 9 by 8 metre pattern across the whole bench, and it defines the seams like you've never seen, the splits and the sedimentological features, and, you know, taking that information into a 3D world and then block modelling blastability type data, identifying our seam surfaces and any splits. There's potential there to, you know, improve the recovery of coal. So I think those are probably our two key drivers that we want to see out of this process: is better definition of our seam horizons, and then obviously the interburdens the drillability or blastability and the hardness of that material to be able to optimise our DMB process.
So from our perspective, besides the outcomes that we're all chasing, it's also being able to provide the information to the right people in a timely manner. And so we're now generating these surfaces on a daily basis. They're going up to site. Drill and Blast can start doing those, use them for their loading rules whenever they need to. They, whatever the schedule demands of them, they're sitting there ready. The other one, insights for me, is the conversations between geology, drill and blast in particular, have grown over time as integrating this data. And we're starting to see buying from the geotechs as well. And so there's starting, a lot more collaboration is starting to happen because there's a common view of the pattern of the data and trying to talk about the risks, the issues around it and how to manage that and what are the implications.
Thanks, John. We're pretty much out of time, but Max, if you had to wrap up the experience in a single word, I think we've had one of the pictures scrolling through with the cat photo. That wasn't an accident.
Yeah, I guess the fuzzy cat became a bit of a legend between us. It's to me, it's all about, that's the exploration image on the left-hand side there, which is pixelated. You can't actually understand everything that's going on. But as you layer up that data of, your BLASTDOG information, your MWD, and any other survey data in the pit, we start making that image get clearer and clearer. So you go from a fuzzy cat to a clear cat. And, that's what we're seeing and going along the journey with IMDEX with in terms of the BLASTDOG project and all the analytics that go with it. So thanks very much.
Thanks, Max. Thanks, John. And thanks, everyone.